Hi everybody. For some reason number 13 got cut off on the practice exam 3, so I'm making just a short video going over number 13. And this is a thin film problem. So a light beam of wavelength 500 nanometers is reflected constructively. That's a really important piece of information there. From a thin layer of oil having an index of refraction of 1.25, the oil floats on top of water index refraction 1.33. What is the minimum thickness of the layer of oil? Okay, so first thing, constructive interference. Here's the idea. Light comes in here in air, wavelength of 500 nanometers. Part of it's reflected from the first surface, hits your eye, and then the light is refracted into this material, bent towards the normal, and then it's reflected again from this surface, and then it's going to hit your eye. So every time light is reflected, we could have a phase change. So this is going from a lower index of refraction to a higher index of refraction. There's a 180 degrees phase change. Same idea here. Lower to higher, there's a phase change. The light hits your eye. So to interfere constructively, we want the light from the top surface here and this surface here to be in phase. So I've drawn out the layers here. Here's N1. It's just air. It's just one. Usually it's air here. Here's the film. So index of refraction of the film 1.25, and then N2 down here 1.33. So when you read through the book, every time they want you to go through and decide if there's phase changes or not. Here I kind of just detailed it. Yeah, there is a phase change here because we're going from lower to higher. There is a phase change from lower to higher. So those phase changes, this one and this one, cancel out. So to get constructive interference, you can figure out what that would have to be. 2t times m wavelength in the film. Now if you don't want to go through every time and decide about these phase changes, I've made this little chart before. I did this for the homework. So this is the index of refraction of the film. This column is constructive interference. This column is destructive interference. So if the index of refraction of the film is the middle value, now that doesn't mean literally that it's in the middle. It's always going to be in the middle. It means the middle value. It's bigger than one of them, but smaller than the other one. So it's the middle value. Okay, so if it is the middle value, it turns out in this problem it is the middle value. For constructive interference, 2t time is equal to the index here. It's 1, 2, 3, 4, 5, etc. Times the wavelength in the film. Destructive interference, it would be 2t m plus a half wavelength in the film. That's where you get anti-reflective coatings, things like that. Constructive interference, we're actually seeing it. Now if the index of refraction of the film is the largest or the smallest value, when that happens you have one phase change on one surface but not a phase change on the other surface. So they arrive out of phase. So for constructive interference the formula is different. 2t m plus a half times the wavelength in the film. And then destructive interference, 2t m wavelength in the film. So when you do these problems, the first thing to determine is constructive or destructive. It'll tell you in the problem. And then once you do that, you have to figure out, is it the middle value or the largest or smallest value? Okay, and T is the thickness of the film. Remember that. Okay, so in this problem, we've determined constructive interference. For constructive interference, we have this case where 2t is m times the wavelength in the film. Now the minimum thickness of the film means that m is equal to 1. That will give you the minimum thickness. Okay, good. So then we have 2t wavelength in the film. Now to get the wavelength in the film, you've got to take the wavelength in the air, divide by the index of refraction of the film. Okay, so 500 nanometers divided by 1.25 gives us 400 nanometers. So let me solve for t. T would be the wavelength in the film divided by 2, and I'm using this for the wavelength in the film. So then the minimum thickness turns out to be 200 nanometers for this problem. That's to get constructive interference. Okay, again, so keep that in mind. What do you have, constructive or destructive? Which one of these formulas are you going to use? Here's the constructive column. Is it the middle value? Use this. Largest or smallest? Use that. Now, as far as the test goes, the practice test had a double slit problem and a thin film problem. This is from the wave optics chapter. In that chapter, we also had diffraction gratings and single slit problems. I did not put that on the practice test, and I did not put it on the actual test. Expect to see, though, a double slit problem and a thin film problem. Okay, sorry about the delay in getting this problem to you. I didn't realize that it didn't work. I didn't watch the entire 53-minute video to make sure everything worked fine. So any questions, email me, and the exam is tomorrow the 22nd at 5 p.m. So make sure you take a look in the week 15 folder so you can see kind of where what it's going to actually look like. Okay, talk to you soon. Bye-bye.